When you think about ransomware, I bet you picture like your computer,
Right.
locked up,
Yeah.
can't access your files.
Yeah, classic scenario.
But what we don't always think about is how this stuff can hit the infrastructure.
Mm.
You know, the systems that power so much of what we rely on digitally.
Right.
So today, we're diving into a really nasty piece of malware. It's called ESXiArgs. And it's not after your laptop. It goes after the big stuff, VMware ESXi servers.
Yeah, we're talking about virtualized environments here, the backbone of a lot of organizations.
And that's what makes this so much more dangerous, right?
Exactly. Imagine, like normal ransomware, it tries to encrypt your files, mess up your operating system, but ESXiArgs, this thing targets the hypervisor. That's the software layer that actually runs all those virtual machines.
Okay, so it's not the individual computers, it's the platform they all run on.
Precisely. It's like instead of breaking into an office in a building, they're going after the whole foundation. And if the foundation goes, well, everything built on top of it collapses.
So this deep dive, we're going to unpack how ESXiArgs works, the damage it can do, and most importantly, what you can do to protect yourself.
For sure. And I think it's worth highlighting right off the bat that one of the main ways this thing spreads is by exploiting a specific vulnerability. It's known as CVE 2021-21774.
CVE, that's the common vulnerabilities and exposures list, right?
Yeah.
So this was a known issue.
Exactly. And it affects a service called OpenSLP. VMware actually released a patch for this back in February 2021.
So problem solved, right?
Well, you'd hope so. But the reality is that a lot of organizations, for whatever reason, they haven't applied that patch. And that leaves them wide open.
So that's one way in. What are some of the other vulnerabilities or misconfigurations that attackers might look for?
Well, outdated versions of ESXi, that's always a risk. Any unpatched flaws in the software itself are potential entry points. But beyond software, there's the configuration side. Like, if those management interfaces for ESXi are exposed to the internet, that's a problem.
Okay, so we're talking about those specific ports.
Right, things like TCP port 443, which is often used for the web interface, and others like 427, 902, 903. If those are accessible from the outside, you're basically leaving the door wide open.
And I'm guessing weak passwords don't help either?
Absolutely not. Weak or default credentials, not using multi-factor authentication, those are huge risks. And then there's network segmentation. If your internal network isn't properly segmented, an attacker who gets in somewhere else can potentially move laterally and reach those ESXi servers.
Network segmentation, that's like building walls inside your network to contain any breaches, right?
Precisely. So multiple layers of potential weakness here.
All right, let's say the attackers have found their target. What's their playbook? How do they actually launch this ESXiArgs attack?
Well, they usually start with reconnaissance, scanning the internet, looking for vulnerable ESXi servers. There are tools out there that make this pretty easy. Shodan, Masscan, even good old Nmap.
So they're essentially mapping the landscape, looking for easy targets.
Exactly. Once they find a potential victim, they try to exploit one of those vulnerabilities. Often, it's that CVE 2021-21774 in OpenSLP.
And if that works,
They get their initial access. From there, it's often a matter of privilege escalation. They use various techniques to get root-level access on the ESXi host.
meaning they have full control.
Pretty much. Next, they'll typically enumerate the virtual machines on that server. They want to see what's running, get a layout of the environment.
So they're basically mapping out their target. Then comes the encryption, right?
Exactly. And this is where it gets really nasty. They're not just encrypting individual files on some random computer. They go after the core files that make those virtual machines run.
And what kind of files are we talking about here? What makes them so critical?
The big one is the .vmdk files. Those hold the virtual disk data, all the operating systems, applications, the actual data inside those virtual machines.
Okay, so that's your data. What else?
They also go after the .vmx files, which contain the configuration settings for each virtual machine. Things like memory allocations, CPU settings, what virtual hardware it's using.
Right, so even if you somehow got your data back, you wouldn't be able to use it without those configuration files.
Exactly. And there are other targets too, .nram files, which store the VM's BIOS settings, and .vmxf files, which have additional metadata about the virtual machine.
So they're effectively crippling the entire virtual environment.
That's the goal, to make those virtual machines completely unusable and force you to pay the ransom.
And what does that ransom demand typically look like?
The ransom notes, they usually demand payment in Bitcoin or some other cryptocurrency. They often threaten to release sensitive data, although with ESXiArgs, we haven't seen a ton of confirmed cases of data exfiltration happening before the encryption. But the threat is definitely there.
And they provide instructions on how to pay.
Yeah, usually through a Proton mail address or a link to a dark web portal. It's a pretty standard playbook.
So we've been talking of the initial wave of these attacks.
Mm.
But has ESXiArgs stayed the same, or has it evolved over time?
Oh, it's definitely evolved. Like any malware that's successful, the attackers are constantly refining their techniques.
In what ways?
Well, the early versions, they mainly focused on encrypting those .vmdk and .vmx files. And honestly, the encryption in some of those early variants wasn't that strong.
So there was a chance of recovery.
In some cases, yes. Security researchers were able to find weaknesses and develop partial decryption tools. But the later versions, they got a lot smarter. The encryption algorithms became much tougher to crack.
Making recovery without the key pretty much impossible.
Exactly. They also expanded their targets, hitting more of those critical VM files, making any kind of manual recovery a nightmare.
So they're learning as they go, becoming more effective.
Absolutely. And that means we need to constantly adapt our defenses.
What are some of the key changes we've seen in these later versions?
Well, they started encrypting more data within the .vmdk files themselves, not just portions of the file, but larger chunks, making partial recovery much less likely. They also started using obfuscation techniques in the malware code.
Obfuscation, that's basically making the code harder to understand and analyze, right?
Yeah, like trying to read a scrambled message. Makes it tougher for security researchers to figure out how it works and develop countermeasures. And then there were the anti-forensic measures, trying to erase logs, cover their tracks, make it harder to figure out what happened after an attack.
So it's a constant arms race.
Absolutely. And it highlights why staying ahead of the curve with your security is so important.
Okay, so let's talk about what we can actually do about this threat. Where do we even begin?
Well, the first thing, and this cannot be overstated, is patching. Patching.
You sound like a broken record.
I know, but it's just that important. We know that a major entry point for ESXiArgs has been this CVE 2021-2121-74 vulnerability. And there's a patch, so keep your systems up to date. Make sure you know what version of ESXi you're running on all your hosts, and have a system for regularly checking for and applying those VMware security advisories.
So keep those servers patched. What else?
If you're not using the OpenSLP service, disable it. You can check if it's running with the command, let me see, ESXi Network Firewall Rule Set List grep, CIM SLP. And you can disable it with ESXi System Settings, Advanced Sedator, User Vars SL Penabled, SAI0.
And just a reminder to everyone, whenever you make changes like that, you need to restart your ESXi host for them to take effect.
Right, don't forget that step. Now, another big one is hardening your SSH access.
SSH, that's secure shell, right, used for remote administration.
Exactly. You want to restrict SSH access to only trusted IP addresses, or even better, disable it entirely when you're not actively using it.
And if you do need to use it, how can we make it more secure?
Use key-based authentication instead of passwords, and make sure you're actively monitoring those SSH login attempts for anything suspicious.
So even if someone gets a password, they can't get in without that key.
That's the idea. And while we're on the topic of access, let's talk about strong authentication for all administrative accounts on those ESXi servers.
Multi-factor authentication.
Absolutely. This adds an extra layer of security even if a password is compromised. You could use VMware SecureID, RSA tokens, implement PAM, pluggable authentication modules, or use role-based access control in vSphere to make sure administrators only have the permissions they absolutely need.
So it's about making it as hard as possible for attackers to get in and limiting the damage they can do if they do.
Exactly. Now, beyond the servers themselves, we need to think about network security.
So protecting those ESXi hosts at the network level, what are some key considerations there?
First off, minimize the exposure of those ESXi management interfaces to the public internet. Those ports we talked about earlier, 443, 427, 902, and 903, they should not be directly accessible from the outside.
What are some ways to do that?
A VPN is a good start. Virtual private network. It forces users to establish a secure connection before they can even try to access the management interface. You should also have strong firewall rules at your network perimeter, explicitly blocking access to those ports from untrusted networks.
So someone scanning the internet for exposed ESXi servers, they won't even see yours.
Right. And if you need to allow remote access for administrators, consider using Bastion hosts. These are hardened servers that act as a secure jump point, so you're not directly exposing your ESXi hosts.
Makes sense. And what about within the internal network?
Internally, you should continue to use firewall rules to restrict access to those management ports, limiting it to authorized workstations or servers. And network segmentation using VLANs is crucial to isolate your ESXi management traffic from your general workloads. You can even implement rules to restrict outbound connections from your ESXi hosts
Why outbound?
to prevent things like communication with command and control servers or data exfiltration attempts. For example, you can use the command esclin network firewall rule set at our SIF server, a trusted out range, to only allow SSH access from a specific limited range of trusted IP addresses.
So basically locking down those servers as tightly as possible.
Exactly. And then, on top of all that, you should have intrusion detection and prevention systems in place, both network-based, like Snort or Suricata, and maybe some ESXi-specific tools. And a good SIEM system for log analysis and correlation can help you spot suspicious activity early on.
SIEM, that's security information and event management, right?
Right. It's all about layering those defenses.
Okay, so we've covered patching, securing access, network security. What about backups? You mentioned those earlier, and specifically highlighted air-gapped and immutable backups. Why are those so crucial in this context?
Because, let's face it, no security is perfect. There's always a chance that an attacker will get through.
So we need that last line of defense.
Exactly. And that's where those backups come in. Immutable backups, they're designed to be unchangeable. Once you create that backup, it can't be modified, deleted, or encrypted, even if an attacker gets admin access to your systems. That means you'll always have a clean copy of your data to restore from.
So even if the attackers get in and encrypt everything, your backups are safe.
Right. And air-gapped backups add another layer of protection. They're physically or logically isolated from your production environment. So even if your network is compromised, those backups are completely inaccessible to the attackers.
It's like having a spare key hidden outside your house.
Precisely. Now, there are different ways to do this. You can use offline media like tape drives or removable hard drives stored in a secure location, or you can have logically isolated backup servers on a separate network segment with no direct connection to your production systems.
And what about cloud backups? Are those considered air-gapped?
Cloud backups can be a great option, but it depends on how they're configured. You want to make sure that those backups are stored in a way that's isolated from your main environment and that they have features like object lock to prevent deletion or modification.
So it's important to choose a provider that offers those robust security features.
Absolutely. That's why we, here at Stonefly, we take this stuff very seriously. We offer Stonefly S3 object storage with built-in immutability and object locking. And our Stonefly backup appliances support ransomware-protected snapshots and truly air-gapped backups. If you want to learn more about our appliances, which also offer HCI backup and DR, AI storage, and cloud solutions, just reach out to us at sales@stonefly.com or visit our website, www.stonefly.com.
So having these protected backups gives you a way to recover without having to pay the ransom.
Yeah.
What are some best practices for managing your backup strategy, specifically for virtual environments?
Well, automation is key. Set up a consistent schedule for automated VM-level backups, whether you're using VMware's tools or a third-party solution. But don't just set it and forget it. You need to regularly test those backups. Do restore drills. Make sure everything is working as it should be. And consider multi-location replication. Store copies of your backups in both an on-premises secondary location and a separate off-site location, like a secure cloud.
So multiple layers of redundancy.
Exactly. You want to make sure you can recover no matter what happens.
Okay, let's say, despite all our best efforts, an ESXi host in our environment gets hit by ESXiArgs. What do we do? What are the immediate steps?
The first priority is containment. Immediately disconnect that suspected host from the network. You need to stop that ransomware from spreading.
So isolate it completely.
Right. Then shut down all the virtual machines running on that host. Stop any further encryption from happening. If you can, try to identify any suspicious processes running on the ESXi host itself. You can often do that using commands like, felagrip suspicious process.
So you're looking for anything that shouldn't be there.
Right. And disable SSH and any other remote management access to that host. You don't want the attacker maintaining control. If you have the capability, capture forensic images of the affected host's storage. That can be valuable for later analysis.
So contain the damage, gather evidence. What about actually recovering from the attack?
Log analysis is really important at this stage. Check those ESXi system logs. Look for any signs of unauthorized access. You can use commands like cat varlo ghostd.log grep unauthorized access. And check the authentication log, see if there's any weird login activity, something like cat_var_log_off.log. Also look for any files that were recently created, deleted, or modified. That can help you understand what happened.
So you're piecing together the timeline and scope of the attack?
Exactly. Now, for the actual recovery, if you have those immutable and air-gapped backups or clean VM snapshots, that's your best bet. Restore your virtual machines from those safe copies. VMware also has a recovery script that can sometimes help restore data from partially encrypted VMDK files. You can usually download it with a command like wget https.github.com from ESXiArgs-recovery, serecovery-script.esh.
And how to use that script?
You need to make it executable first, using chmod +x serecovery-script.esh, and then run it with se-recovery-script.esh. If it works, you'll need to re-register or reattach those restored virtual disk files to a new or existing VM. Of course, here at Stonefly, we specialize in this stuff. Our backup and DR solutions, including our HCI and cloud options, are built with ransomware resilience in mind. We offer that critical air-gapped and immutable storage. If you want to learn more about how we can help you build a robust recovery strategy, just visit us at www.stonefly.com or email us at sales@stonefly.com.
So it sounds like being prepared is everything, having those multiple layers of security and a solid tested recovery plan.
Absolutely. Proactive security is essential against threats like ESXiArgs. Patching, securing access, robust backups with immutability and air gapping. That's how you minimize your risk.
And having a clear incident response plan.
Absolutely. Knowing what to do when an attack happens can make all the difference. We offer a full range of data management solutions, including air-gapped and immutable storage, HCI, backup and DR, AI storage, and cloud solutions, all designed to help you build a resilient infrastructure. To learn more about our AI storage, HCI, backup and DR, and cloud solutions, all with air-gapped and immutable storage, visit www.stonefly.com or reach out to us at sales@stonefly.com.
It's not a matter of if, but when these days.
Right. You have to assume that you could be targeted.
So focusing on preventing irreversible damage through those recovery mechanisms is key.
Absolutely.
Well, that was a fascinating, if somewhat terrifying, deep dive. Thanks for joining us.
My pleasure. Thanks for having me.
And for our listeners, tune in to our next podcast we'll be taking a look at. Well, you'll just have to wait and see.